Okay. Uh, can everyone hear me? Let me see how bad the latency is here. Do, 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 do. Let's see. Okay, cool. Great. So, welcome to this Epic Week live stream on Build Your Own Code Generator. So, the first part of this, I'm going to kind of have a quick slideshow, kind of talk about code generation for Java, some little high level ideas, and then the meat of this talk is really just building some code generators. It's meant to be interactive, so please ask questions as I'm doing things. I'm happy to explain things, and yeah, let's get going. Unfortunately, there's still a few people on the Zoom stream, but I tried to be as explicit as possible to move people over. Yeah. So agenda. First, I'll talk about Java compilation annotation processors, why you should or should not use it. Hopefully, like a rule of thumb that might be helpful here, and then we'll build some code generators. And it's a little bit ambitious. I don't think we'll get to JSON deserializer, but who knows? Maybe we'll fly by and see how it goes. So to start, the Java compilation is very complex. It has this annotation processor built in. So here's the Java doc. It's very helpful. And I think in order to really understand this, you have to kind of like look at this compilation document. So essentially, when you run javac on a class file or a Java source file, first it parses it, and then it kind of looks for anything that can process it using annotation hooks. And then it has this like concept of a round. And so it's actually like an infinitely repeating process here. And the way this works basically is that at any phase, or any round, I should say, the compiler keeps track to see if any of the processors emitted new code. And then it'll kind of finish once nothing has added new code. And so this is a way to handle processors that are dependent on each other, right? So if in my JSON serializer example, we're going to have code that depends on immutables. Immutables generates code, and so we have to have a way to be able to handle depending on other processors. And so that's essentially what this allows you to do. Yeah, so moving on. Any questions about this? Okay, I don't think so. Moving on. So one thing that's like important to know, and this is kind of like a general Java thing, is the annotation processor hook works by what's called service loaders. And you can kind of see the Java doc here. We actually use service loaders occasionally in HubSpot. I kind of view it as the Java provided like dependency injection, right? So we're used to Juice. Service loaders allows you to basically write down in a file that a specific class is going to implement another interface, and then it provides a hook in order to load all the implementers of an interface. And it's pretty straightforward. We don't really need to get into the weeds here, but essentially, if you create a file in your class path like this, and each line is the name of a class, at compilation time, that depends on how you configure the compiler. But the way we have it configured right now is that it'll essentially accept any annotation processor and check to see if there's work to do for each class that matches annotations. So let's go a little further. So pros and cons of code generation. So there's like definitely a lot of really compelling reasons to use code generation. So the biggest one in my mind is that it can turn runtime errors into compile time errors. And I think we'll see that a little bit with the JSON serializer, but basically we're moving logic into compile time. And so, there's a whole set of things that can happen at runtime. So if you're using Jackson or something like that, and you don't really know at compile time, we have no idea what Jackson's going to do with a specific set of classes, right? Like it could work. And generally Jackson has been battle hardened over time and it works really well. But if it does have an error, you'll typically only see that at runtime. You could generate faster code. And so, right, like you could spend time to like actually, write static code that does exactly what you want it to do. And you don't have like the overhead of reflection or any other type of like things you might do at runtime, right, to get around reflection speed. And then, generated code could be inspected in the editor. And that's something that like one of the things that you try to do when you're writing generated code is you want to be readable, right? You want it to be something that like an engineer could look in the IDE and see the implementation and actually read through it. And, I'm sure everyone here is familiar with immutables. And immutables kind of can get long in a tooth. Like you'll see very long Java file there, but the point is it's relatively readable. It has comments and everything like that. All right, so cons. So there's a lot of cons, and I want to make this really clear to people. This is not something that like I want everyone here to use as soon as you're done, or as soon as you're done with this talk. Like, I don't think everyone here should write a code generator. One major con is that generated code is not in source control, and so, this is something that like we run into with Chirp a few times, where it's like, it would be nice to be able to look at Chirp clients, but they're not visible, right? They're kind of like implied based on the Chirp service that is in source control. You have to think like a compiler, and this is kind of tricky. Something that you learn after writing a code generator is that you have to like handle all the various edge cases. Like people will have crazy type resolutions, and there's only, because of the place at which an annotation processor runs, you don't have all the niceties that Java compiler does for you, right? So like you'll see some of this maybe, but some of the like generic type resolution or other things like that, like sometimes some of the utility methods I had to write, I felt like I was trying to be a compiler, and it's kind of annoying to handle all the various edge cases. Rolling out changes is super hard, right? Because not only we're used to like dealing with library like interface changes and how you roll that out, but there's kind of like the second order difficulty of like pushing, like if you want to change a runtime interface, you have to know that like, okay, well, there's going to be code that exists that was compiled against your old version of the annotation processor, and then this code that exists in the new version of the annotation processor, and you have to like handle that case. And so there's a few cases where we've, in Chirp, we've had to make breaking changes, and you had to like generate you had to like generate a like intermediary step where you build the whole world, and you kind of like build a shim, and then you wait until the whole world builds, and then you can make the breaking change. Sorry, I think this is like the wrong, I don't know, for some reason anyway, let me look at my preview really quick. Yeah, for some reason the screen is like really small. I don't know. Let me see. Okay, we'll see if this is better. Okay, and then there's like two levels of testing. So similar to rolling out, you have to deal with like testing the actual compilation output and also testing runtime behavior, right? And so as you'll see, like testing the compilation is actually really gratifying, and we'll see how to do that. But then you also have to write a library to test runtime behavior. And then it can make compilation slow, and this is really annoying. Like the speed of compilation is because of the way the rounds interact, right? So it's not just the speed of it's not just like the incremental performance impact of like your code, but there's also the fact that like you have to like enter into a new round, and if you have like different processors that depend on each other, you might have to like go through this round a bunch of times. Or if you have like a processor that generates classes that are dependent on each other, then you might have to like enter the round a few times. And so it can definitely like slow down compile time. And we've definitely seen cases where, you know, IntelliJ will just like refuse to do like over 10 rounds or something like that. And then you get some weird errors where it's like, hey, like, you know, the class doesn't exist or something like that. And it's like, we're like, hey, sure, like we generated that output, so it should be there. So yeah. So rule of thumb, I think like the way I think about it is like, you don't want to write code generation for any product specific logic. So it's great for like really low level, you know, like immutables or like code that I want to share for records, or I have like a single value type. It's like a very generic thing. Chirp is like a very low level infrastructure, but I would definitely caution against putting like business logic or product specific logic in a code generator, just because usually you can get away with not doing it. Like I think, you know, there's a certain level of complexity that you're adding using code generator, and like you really have to get the benefit off of that complexity. And one way you can get the benefit is just by having lots of use cases across a lot of different users. And so that's how I would view this. Cool. So let's begin writing our first annotation processor. And so this is this project Marvelet, which I'll talk about why I named it this later. So this is Marvelet Gen, Marvelet runtime. Here, let me turn music a little bit. Yeah, that's what I'm looking at. Okay, so let me see. Okay, so let's build our first annotation processor. How'd that even show up? Man, look at this. You guys are sleuthing all over. All right. So let me I don't know if this is Minecraft. I don't know. Anyway, so to start, we need an annotation to mark our processor. So I'm just going to create this Marvel annotation. Wow, this is cool. And the target will be type, and retention, we can just leave source. And then let me see. We also need to tell, there's like a overrideable method here to get the annotation types. Pretty simple. So now we write a process method, right? Yeah, this is supposed to be like simple music. Yeah, I'm definitely going to be looking at a I'm definitely be looking at our stream analytics at the end of this to see what our max concurrent view count is. So if you guys can try to recruit more people to view this, it'd be helpful for my monetization. All right. Anyway, so we have this class here. So this round environment. So like I said, the Java C compilation happens in rounds. And so this is the environment for one specific round. And then you can ask for all the elements annotated with Marvel. And if it's empty, let's just return false. So this process method, you return true if you don't want anyone else to see your class, or any other annotation processor to see your class. Yeah, I know I could use AI assistant. I thought about using it, but I'm still getting up to speed on it. So unfortunately, we'll have to wait for that. Is this on YouTube for the 60? I don't think there's gonna be an ad break. We'll see. Because you're all using the HubSpot org, so hopefully, let me know if there's an ad break. I hope not. So let's just do something super simple. Whoops. First element, and then what we're going to do is we're going to take the filer and we're going to create a source file, and I'm going to call it my file. And what this does is it takes in the name of the class and then the element that originated that that file. And let's round it bycatch. And then we can open a stream. Actually, I think we can open a writer. Yeah. This is going to be the simplest possible file. All right, look at that. So, yeah. Okay, so let me see. Are you guys? Is the chat showing up in the screen anymore, or is it gone? All right, we'll see. Let me return false. All right, so now the question is like, how do we run this to see if it actually works? No, it's there. So you don't need to append class. So this is just the class name. So actually, like if you did com.hubspot.myfile, then we do package com.hubspot like that. So anyway, so this is generating. So the question is like, how do you actually run this processor? We can build the jar and then include it into another package and then have it run, but that's a lot of work. So to make this simple, there's a test harness that we have, and you can basically Google provided this like way to run Java-C pretty easily. You provide the list of processors, and then you provide a list or a stream of files, and then it runs and generates fixtures that you can then compare against in the future. So to look at this, so I have this simple processor test. This is in a resource, so it's not a regular source file. Our Maven structure plugin requires that Java files are either in your Java code or they're in the special Java files folder. Let's add the annotation here, and then we can try running it. And I have to rebuild. Let's see how this goes. Oh my gosh, it worked. I'm like really worried. All right, so essentially what this fixture does is it writes the outputs out to this like generated fixtures folder, and then here's like the output. And so you can see we generated a class here, and it's really simple, right? So it just has my file. So there we go. That's all we need to do. We're done. Yeah, so obviously, like this is not that interesting, right? It's like the simplest possible processor. If you want to do anything more complex, there's like a couple of libraries that we'll have to introduce. So the first one is called Javapoet. And it used to be run by Square, but Palantir recently adopted it. And when I say recently, I mean last month. So everything we have is using Square. And I apologize. Soon we'll be using Palantir's version. But here's what it looks like. So, you know, it's kind of annoying to write strings for source control. So what Javapoet is, it's a structured, statically typed kind of set of building blocks in order to format code for you. So here's an example. We have a method spec, so you can build a method and you give it modifiers and it returns void, and you add parameters and you add a statement, and it has this like little formatting thing, and it's very helpful, right? It does a lot of things that you want to not have to think about, right? So for instance, like if you put a $T here and you put a class name here or type name here, it'll put an import statement for that type. It's really annoying to have to do that all manually. It remembers semicolons. There's just like so many features, and as you use it more and more, you really appreciate it. So you have a method spec, which is kind of like probably the smallest thing. Well, code block is probably the smallest unit and then there's method spec, and then with method specs you can build type specs, and then with a type spec you can write a file. So it's pretty nice. So that's one big library to keep in mind. And then the other library that helps us a lot is this thing called Turbine, which Zeb wrote after a lot of like frustrating experience writing code generators. And essentially what Turbine does is two things. One is it provides this like juice injection. I didn't write it. Okay, I've abused it. I've added a lot of stuff to it, but you know, I'll give Zeb the author credit here. But essentially, it provides like juice injection or juice kind of like small juice environment for you to inject different things, and we'll see why that's useful. And it also allows an easy way to express deferring of process of work, right? So, kind of going back to the whole round business. It's kind of unintuitive on how to handle like, oh, like I want to reference a class, but the class isn't compiled yet. Like, how do I handle that? So Turbine has this like deferred exception that makes it pretty easy to handle that. And then it also like it's opinionated, so you could generate, you know, kind of remove some of the boilerplate of like the file writer or like how do you print exceptions out to the end user and all that stuff. So it's pretty nice. This is what we're going to use for this project. And so we're going to write Marvelette, which is a band name, which is a competitor to Jackson 5. And we're going to write a JSON serializer. So let's see how this works. So let's rephrase this. This is going to be, and there's one L. Okay. And then, and we'll put it on a type, and then the example. So let's write an example first. That's what I always like to do. Let's rename this. I'll just do my immutable. Listen, I'm like, part of the point of chirp is to get rid of Jackson, I feel like. So it's not quite far off to say that we want our code generating is going to power us to get off of Jackson, but that's another story. Okay, so here's my example, right? So I want to have an immutable here, and I put Marvelette serializer on it, and then it should generate a serializer, right? And so what does that even mean? Well, first we have to like have an interface to implement. So I just started writing this like interface here. It takes in a string builder, which is where you add the JSON strings for the object. And so like we would like to have an implementer for the serializer. Note that I have these two, you'll see this a lot in code generators where you have two companion Maven modules. So we have a runtime module and a gen module. The gen module is for the actual code generation, and the runtime module is for the actual runtime. This is really nice because the dependencies for the gen, the class path of the code generator don't actually end up in your runtime, right? So you can get away with putting stuff in here, kind of, and then you won't be bloating someone else's code. So for instance, like if you have, let's say you have juice in here, which we do for Turbine, and you reference this in a models project, which we do for chirp, we don't want to have juice pulled into those models as a direct dependency at runtime. So yeah, so I have this runtime, and this runtime I think has no dependency. So it's just this interface. That's all it is. And then I want to generate a serializer for this. So let's start by creating the processor. and I need to put this auto service. So whoops, my okay, something weird happened. So this auto service is itself an annotation processor, and I kind of skipped that with the simple processor. But this is a Google provided code generator that generates the manifest file to bind service loader. And so we're using the code generator to make our code generators easy to write. And I need to create a module here. I have one. Okay, and then I need to write a turbine generator. Oops. Okay. Is there anything else I need to put in here? I think that's it. Oh, I need to... No, I think that's it. All right, we'll see. What can go wrong? So in the serializer generator, so, importantly, like I said, I'm using Juice, so I'm injecting the generator here. And it has this like thing called tools, which has a bunch of helpful utilities that we'll use soon. And then I think there's a generate method here that I want. And then I want also to mention which annotations I care about. And then this is the hook that I need to generate my serializer. So to start, let's just return something really simple here. Class builder, my first serializer .build. All right, and let's see what happens here. Oh yeah, I need to put in the Marble processor, and then importantly, there's this like I'll never find it. So Immutables has a processor in it too. It's in the value. Does anyone know what the name of it is? Oh, well, it's gonna be in here. All right, proxy processor. Okay. There's another one. This proxies into another one that I think we can use, but oh, this one maybe. All right. So this is gonna be. We need. Yeah. I got there. I didn't want to cheat, and steal it from our code. So this is a list of processors I need in order to run a test, because I need the immutable processor in order to generate the immutable, and I need the Marvelet processor in order to generate the serializer, and I need the auto service to run our processor. So let me get the test here. So the test file is called myimmutable if, and then let's try again. Let's see what happens. All right, so something ran. So it generated my first serializer, and this is really basic here. The dollars are pretty well. So looking at this generator, right? So all we did was we just we told it class builder. We didn't add any modifiers, so it's not public, and we didn't add any package. So it's just I guess it took the package from the element. I have to figure out where it even got the package. I think Turbine probably inferred the package from the element. But importantly, we also added this like generated annotation, which is really helpful for code generating output, so that like, you know, if you ever do look at a source output from a jar, you can know that it was generated and where it came from. And you know, this is helpful for like understanding why code is the way it is. But let's actually start to scaffold out the type builder here. So the element here, it should be a type element. So I'm gonna do an instance of check here. This should never happen because the target of the annotation is type, and so we shouldn't see this be anything else. So there's the serializer. So this is like really annoying, right? So the type element is going to have a simple name. Javapoet has this really helpful thing called class name, which is kind of like an immutable version of some of the Java things. So here I have this class name, and class name has package and simple name. We need the serializer simple name. Here, I'll just do... You know, at one point I'll just ask AI to write this for me, but for now, I don't. Whoops, simple name. This is the type of stuff you have to do that's really annoying when you write code generators to like handle all these different cases. And I'm not even handling the like interclass or like, you know, static interclass stuff that happens. All right, cool. So I have a serializer name here, and so let's put this here. And then we can add a super interface. Oh yeah, and then I also need the impl name. Actually, let me do that. Let me call this model. This is going to be the immutable. Okay, so I'll just copy this or cut it. Whoops. Okay, simpler. So we have all of our names. It's like really basic stuff here. And the reason why I need the model name is because the super interface is generic, right? So I need a parameterized type. And this is like a Javapoet thing, so you can add a class name and parameters, right? So the class name is going to be the serializer, and then actually let me do class name .get. Oh, there's two serializers. That's cool. I should probably rename this. And this is going to be the model impl. Oops, didn't mean to delete everything. What happened? All right. Yeah, so this is expected. So the I generated output, but the but I didn't override the method that I need to override here, right? So that's an important problem here. So let me do that really quick. Over and let me see what the name of this is. Serialize parameter. And then there's a name allocator here which we need to use to avoid collisions. And this is, you know, what you expect it to be. It's just a set. And if you ask for model twice, it gives you model with some sort of disambiguating value here. And I think it's void, so I don't think we need to even add any code for it to compile. So let's try it. Oh, I need to make it public and over. And let me add an override annotation. Okay, so we generated the serializer, and right now it's really basic, right? It just it does something, you know, serializes. One issue is right now we're not doing anything to like handle if this immutable doesn't exist yet. So I think we can put some check in there really quick. And the easiest way to do that is let me put tools here. Get type element. There's a lot of toString that happens in the Java, like the Java C ecosystem, which is a little annoying, but that's fine. Impl type element. So we're just going to run this defer exception here, and this just allows us to handle cases where rounds weren't there. You can see actually Turbine will tell you the various rounds that ran, which is very helpful to kind of understand what's going on. So it took us 3 rounds to get to 0. And it times each round too, which is helpful. Okay. So now we have to actually write the serializer. So there's a few different things we have to do. So I guess like let's you know, write a method to do this. Pretty simple. And I need the type element. And the impl. What do I need? Do I need anything else? Oh, I need the name allocator. I need the output parameter and the model parameter. And this should be a code block. So there's a few things about, I guess for now, let's do something really simple. So I was thinking like there could be a field with JSON value in it, but I'll deal with that if we have time. It's already 9:44, so we don't have a lot of time. So let's keep moving. So first we need to find all the getters that should be serialized to JSON, right? So that's what we should do is use this element filter thing, which is part of Java. Methods in type element.get those elements dot filter. And how do we know if it's a getter? Well, it should have no parameters. And what else? It should not be static. There's a bunch, but I'm gonna just do some simple ones just to get moving. The annotations shouldn't contain JSON ignore. And let's just start with that. And these are all the getters. Is there any others? I think JSON will just kind of do everything. So this is pretty good. And then for each of these, well, to start, there's kind of going to be a recursive step here, right? Because we have to kind of go through each message object or each model object kind of recursively. So to start, let's write output dot append open bracket here. So let's do and then at the end we'll make sure we add that. Whoops. And these little $sign template things are really helpful. You can read the template language in Javapoet, but basically $S means escape it as a string literal, and $L means that this is going to be some sort of variable or some sort of literal expression that you include. And then for each getter, so let's just compile this and see what it generates. It should be something reasonable. Did I forget? Oh, add statement. This is what Zev was talking about with semicolons. You have to make sure you write the semicolons and indent and everything like that. So add statement will generate all the semicolons we need. So here's the simplest possible serializer, but doesn't do any fields yet. And so we have to generate the getter or generate the field for this. So we need a field name from executable element. Actually, I don't really want to do let's just get rid of that. That's stupid. Okay. And I think that's all we have to do. I guess if JSON, there's a JSON property. Well, I'll deal with JSON. It's 9:49, so. Okay. Oh, I have to do. I have to handle like the case of having printed. So. Da, da. This is going to be like output, and then I have to like put quotes around the field name. Let me just try writing null here. Oh yeah, I have to convert the name here, field name. Okay, so this is going to generate null values for each field, which is very exciting. But let's actually try to generate like something interesting here. So let me create a type handler here. Oops. Type okay. What can I not support here? Object? No, object is not primitive. Boolean. I think void is not primitive, so it's fine. So this is the kind of stuff that Javapoet makes really easy. You can kind of interact with whether or not something is primitive and boxed and all that stuff. All right. So this is a number one. So a number we just call the getter. Yeah, code type mirror is a fun issue interface here. It basically it's kind of a signal interface, but I don't really have time to go into that right now. So unfortunately, and this is going to be dot. Okay. And then module here. I also have to make this juice injectable. Okay. We inject this. Okay, we're almost there. Let me just write a string one really quick. And actually, we can make this handle char sequence as well. So let me do that. I'll have to get the type mirror. And then this one is going to be hopefully this is enough. This is the type of thing AI would be really good at. All right. Okay, let's run. Whoops, I didn't put it in here. So this type handler stuff basically allows us to, dispatch, because we're gonna hopefully our serializer will handle all sorts of types. I have a lot of ambitions here. I probably have is assignable backwards here. The boilerplate for using an injectable. Yes, that's part of Turbine. So Turbine provides these tools and such available to us. All right, so yeah, it works now. So it detected that get bar implements char sequence, which is something that like append will handle. And it'll do this. Obviously, I didn't have time to do the JSON escaping of the string, but this is a basic serializer here. And this is all at compile time. So unfortunately, I think this is I'm out of time. Does anyone have any questions? the music a little down. Oh, would a text block work instead of wrapping field name in? I don't know. Like I mean, if you mean like the Java text block, yeah, I'll put a YouTube link in. Yeah, text block could work. You could pass in multiple quotes. Yeah, one related project that Zev and I noodled on was like a compile time SQL mapper, which is basically the same thing. That's why I kind of was inspired to do JSON serializing as an Epic Week talk. Cool. Well, I think yeah, I mean chirp is basically at its core a compile time serializer and deserializer. That's like most of what the compile time code is, I think. Zeph can correct me on that, but there's obviously this code around like generating calling the clients and everything like that, but there's a lot of logic in the serializer and deserializer. Cool. Well, thank you everyone for stopping by. We have a Epic Week spotlight with Andy, so please join that. And yeah, see you around.